Now we're going to look in stoichiometry in the detail as seen from conversion factors. So let's suppose you had 0.5 moles of nitrogen. You want to know how many moles of hydrogen you need. To use conversion factors, you would start with the one you know, which is 0.50 moles of N2. Then you want to get rid of moles of N2. You would write that here. And you want to go to moles of hydrogen, which is right here. And you look at your coefficients 1 and 3, so you put a 1 right here and a 3 right here. So now you know that you have 0.5 times 3, which is 1.5 moles of hydrogen would be necessary. And you'd write your 1.5 right here. Let's suppose you want to get the last blank over here for the ammonia. You start again with your 0.50 moles of N2, and then you want to get rid of moles of N2. Change it into moles of NH3, and there is 1 mole of N2 for every 2 moles of NH3. So you write this down, and you multiply that and you get 1.0 moles of NH3. So there's a significant amount of writing to do this, and what I'm going to show you right now is what I call the bridge method. And the bridge method is exactly this mathematically, but a lot easier way to think about it and a lot less writing. What you need to remember about the bridge is simply to divide and multiply. It's very similar to proportions, which you could watch my other video on proportions to see that connection. But all you have to remember is divide and multiply. So you start with the number you have, which is the 0.5. You divide by the coefficient, which is 1. So divide by 1 is 0.5. Then multiply by the new coefficient, 3, and that's going to be a 1.5. It's exactly what you did in your conversions, because look, 0.5 divided by 1 times 3. It's over here, 0.5 divided by 1 times 3. You're doing conversions, but just not writing it out. And then to get this answer, the 1.0, all you have to do is do 0.5 divided by 1 times 2, and you get 1.0. That's exactly what you did in your conversion right here. You did 0.5 divided by 1 times 2. And you got your answer of 1.0. So applying this to the second example, you would take 12 divided by 3, which is 4, times 1, which is 4. And that's what you would write over here, 4.0. And then we'll do it again for the second answer. 12 divided by 3 is 4, times 2 is 8. So that's going to give you an 8.0 answer over here. You would do the same thing for molecules, which are particles, divide and multiply. So if you take 2.4 10 to the 23rd divided by 2, 1.2 10 to the 23rd, times 3 is 3.6 10 to the 23rd. So we're going to write that here, 3.6 times 10 to the 23rd. And then to bridge to the one on the left, you would do 2.4 10 to the 23rd divided by 2 times 1. That's going to give you 1.2 10 to the 23rd. So this is what I call the little bridge, and that works for particles right here. It works for liters of gas, and it works for moles. But if we're going to talk about grams, it's going to be a little different. So let's take a look at that. If we go to the next example down here, it says that you have 6 grams of hydrogen, and you want to figure out how many grams of nitrogen do you need for that. So with conversions, what you would do is you would say 6.0 grams of hydrogen, and then I'll just plan it out and then we'll figure out the numbers in a minute, okay? You want to get rid of grams of hydrogen, and then you could go to moles of hydrogen, and then you want to get rid of moles of hydrogen and go to moles of nitrogen, and then you want to get rid of moles of nitrogen and go to grams of nitrogen. So let's fill in our numbers now. Every 1 mole of hydrogen is 2.0 grams of hydrogen. And in the balanced equation, you could see the coefficients. The 3 goes for the hydrogen and the 1 goes for the nitrogen. And then with grams of nitrogen, it weighs 28.0 grams per mole. So now you do all that math, and you're going to get 28 grams of nitrogen. So you had to write all that out to get this answer right here, 28. Now what I'm going to do is I'm going to show you what I call the big bridge, which will save you all that writing and still give you the same answer with the same mathematical process. So this is called the big bridge. Now no one's going to understand that except for people in our class here, so just don't go talking to any professors about this. The big bridge, you just need to divide 2 times and multiply 2 times. So here's how it works. I'm going to point and show you. Then I'll write it out for you. 6. 6 is the first number. So now we're going to divide by the coefficient and divide by the molar mass, and then multiply by the new molar mass and the new coefficient. So you're going to do 6 divided by 3, which is 2, divided by 2, which is 1, times 28, which is 28, times 1, which is 28. So that's going to give you this answer right here, 28. Okay, everything I just did is exactly what you did in your conversions. So let's look. I did 6 divided by, just get this here, 6 divided by 3 and divided by 2. Okay, so where do we see that? We see that over here in the conversion. 6 is here, divided by a 2 and a 3. So we divided by these 2 numbers right here, the 2 and the 3. And then look what we're going to do here. We're going to multiply by 28, multiply by 1, and get our answer of 28. And look, we multiplied by 28, multiplied by 1, and we got our answer of 28. So the big bridge is actually doing exactly what we learned before in the conversion, but not having to write it all out so detailed. So let's do the last blank on this one. And we're going to start with our 6. So start with 6, and we're going to point here and go 6. Then we're going to go divided by 3, which is 2, divided by 2, which is 1, times 17 is 17, times 2 is 34. So now we have 34 over here, 34.0, could do. Sorry, the pen is not really working very well. So that's 34.0 is going to be our decimal right here. And it's the same thing as if you had done all the conversions, and you'll notice that the left side equals the right side. Okay, so I'll write this out for you one more time just so you see it. How did I get the 34? I did 6.0 divided by the coefficient, which is 3, divided by the molar mass, which is 2, times the new molar mass, which is 17, times the new coefficient, which is 2, and that's going to give you your 34. So let's talk through briefly the next couple. I'm going to make this a little smaller so we can fit it. And let's see it right here. I'm going to coach you through the bridge for the next one. So 42 divided by 1 divided by 28 times 2 times 3. That's going to give you a 9, 9.0. And then we'll do the last blank is 42 divided by 1 divided by 28 times 17 times 2. And you're going to get an answer of 51. 51 grams is going to be your final, and again they add up because of the law of conservation of mass. So what I would do if I were you is I would pause the video and try the next example, and then as soon as you're done, resume the video and see if you got it right. Okay, on the last example you should have gotten 14.0 for this answer right here, and you should have gotten 3.0 for this, and they add up on both sides. So my recommendation, of course, because it's the way I like, but you could do whatever you want, I would save myself all this writing right here and do the bridge. And if you ever have to show your work on a test, all you have to do is write this. And on the AP exam, this is actually completely okay to write. As long as you put a unit on your answer, it's fine. You don't have to show all the units here specifically on the AP test. Now, I've heard in college they make you do this a little more detail with the conversions, okay? But for now, if you understand this, I would just totally do that to save yourself a lot of time.